Thank you, Sarah. Now I invite Lentin Joseph sir to take the session. Sir, please.
Okay, so I think we can start. I think my voice is audible.
Yes, sir, audible.
Okay. So today we are planning to discuss about robot programming and a platform called Robot Operating System. Okay, so I'm planning to make this session as interactive as possible. Okay, so in the Google Meet you have the chat box. Okay, so what you have to do is when I ask some questions, you can comment it. Okay, so instead of unmuting your microphone, you can just comment. Okay, so I think already one guy is saying a hi, wonderful session by. Oh, I think he already grabs all the topics of this talk. I think anyway, I hope the people joining this talk maybe having some interest in robotics. Okay, so I will ask a few questions like that is during the meeting. I mean during the talk, and so make this talk as much as interactive. Okay, and I also want to take 15 minutes for the Q&A. Because this topic, that is the robot programming and robot operating system, is a vast topic. So I'm only giving some introduction on this topic, okay, today. So in the Q&A session, you can ask more questions related to your project. Maybe you don't need to limit the questions to robot programming and ROS. It can be anything related to robotics, okay? Yeah, now we can start. So just an intro about me. My name is Lentin Joseph, and I'm working as a robotics software consultant. Okay, I'm running a company called Qbotics Labs. Okay, it's in Kochi, and I have an online blog called RoboAcademy. Mainly, I'm sharing tutorials regarding robotics and robot programming. Then I have few experience in working some robotic startup, as well as Carnegie Mellon University, that is in US, for some time. Then I have masters in robotics, and I also spoke in TEDx. Okay, and I have written 8 books in robot operating system, mostly related to, Python, C++, ROS, OpenCV, those topics. So these are some of my books: Robot Operating System for Absolute Beginners, Learning Robotics Using Python. Yeah, so mostly the books are related to ROS programming. And these are some of the books I reviewed. I didn't include all the names, but these are some of the titles. Okay, so I'm planning to give an introduction to robot programming and introduction to ROS. Then we can see some of the steps for installing ROS, then ROS architecture, communication model, client libraries, etc. That if we have enough time, then we can cover all those topics. Okay, and at the end of the class, I think I can show you some demos also. So that is my plan. And I'm using Ubuntu 20.04 and ROS Neutic version. So you don't need to bother about. I will just show some demos. Okay. So let's start. So how many of you already working with robotics project? So you can put the comment in the chat box. Okay, so just let me know how many of you are working with robotics project or worked with some kind of robots. Let me know. So I think there are 84 people. So is there anyone already worked with robotics, or how many of you are interested in learning robotics? So just give a comment. I think nobody's commenting. Yeah, it's coming. Yeah, okay. I think few of you are interested. I think I'm only getting 2 comments. Okay, fine. So I assume that some of you have interest in learning robotics. Okay. So I can start with the basic blocks of robotics, robot mainly. So yesterday, I think you already covered the basics of robotics, robots, and I think there was a live session yesterday, right? Yeah. But I just want to start from here. So the main modules of a robot is it will have a sense block and think block and act block. Okay. So sense block consists of the sensors, meaning the cameras, then the depth camera, then the lidars, laser scanners, etc. That is a sense block. Then the think block, that is the block that is taking decisions, okay, based on the sensor output. Okay. Now, the final block is the act block, which is executing the decision made by the computer or the think block. Okay. So these are the important three blocks inside a robot. Okay. If you take any kind of robot, you can see these kind of three blocks in that robot. Okay. And basically, if you check the diagram, this diagram, you can find this is a physical robot. Okay, so if you build a robot, it will have some sensor reading, and that sensor reading is feeding to a control computer, and the computer will process and take decision, and it will feed to the robot again. So the robot will have some actuators, so the decisions will be executed in the actuators. Okay. So this is a sense, think, and act loop. Okay. So this is an example for an obstacle detection robot. So the sense loop will find the obstacle, like, hey, there is a wall on the front that is 5 centimeters away. Okay. And that is actually the sense actually detect that obstacle, and it will feed to the think section. So think section will be like taking decision based on this sensor value. Okay. And after taking the decision, it will pass to the act. So depend on the decision, maybe the robot may move back or move front. Okay. So in this case, the robot will move back. Okay. So this is a detailed diagram of a robot. Okay. So this is the act unit, basically the actuators meaning motors. So there are different kinds of motors, right? Stepper, servo, then DC gear motors. So these belongs to the actuators section, that is act section. And in the sensors, as I mentioned, there are a list of sensors available, and there is a think section that is mainly consists of computers or microcontrollers, single board computers like Raspberry Pi. So our focus will be mainly on to this think section. Okay, in this session, we are focusing on to this think session. So this is responsible for taking decisions in a robot. Okay. So let's jump into the main robot components again. These are some of the examples of sensors. There's a camera, wheel encoders. You might hear about wheel encoders. It is the function of wheel encoders is to detect the speed of robot wheels. Okay, so that is there. And ultrasonic sensors. Let me close this. Okay, ultrasonic sensors. You might use ultrasonic sensors in your project, maybe for detecting obstacles. Okay. Then the examples of our focus will is mainly into the computer. So we have the PC. So you maybe heard about Intel NUC. This is a mini computer from Intel, okay, which can be used in robots, okay, because of the small form factor or small size. You can put this in robots, okay. And there are a lot of boards from NVIDIA. So NVIDIA TX2, NVIDIA Nano. So there are a lot of boards from NVIDIA. Then you might heard about the Arduino platform, that is a microcontroller platform. Okay, so this can be also used as a brain or think section in the robot. Okay, and there are a lot of microcontroller boards are available. Okay, so one of the popular board is Arduino. So these are the actuators: servo motors, stepper motors, DC gear motors, industrial servo motors. Like if you're planning to work with industrial robots, that is manipulators. You might see robots that is working on car manufacturing industry or material handling. So in that robot, we are using industrial servo motors. And these motors are called smart actuators, which is basically servos, which can handle much payload, and it's an intelligent actuators because it is having a lot of settings inside these actuators compared to DC gear motors and stepper. Okay, so these are some of the example, and these are some of the examples of sensors. This is an IR sensor. This is an ultrasonic, and you might have seen Google self-driving car, right? The car driving without the driver. Okay, so in those kind of robot, that is actually a robot. Okay, so we are using a LiDAR called Velodyne. Okay, the Velodyne is one of the popular LiDAR that is using in self-driving cars. And we have the laser scanner, then the depth sensors. Depth sensors means the regular webcam that we are using in our laptop can only give the 2D image of the environment, but the depth camera can give you the 3D information of your environment. Okay. Yeah, so that's a sensor. And the important section, that is a compute module, that is Intel NUC. This is an Intel NUC. So you can see this is not like a big desktop CPU. It's a smaller computer with all the functionality. Okay. Then we have the Raspberry Pi, the famous Raspberry Pi, which is called the single board computer. Okay, then this is the TX2 module, then Odroid, which is very similar to Raspberry Pi, and we have industrial PC, which is used in industrial robots. Okay, so what is robot programming? So I can explain what it's a modeling of the behavior of a robot. Okay, using a programming language. This is the simplest definition. So, for example, you might heard about line follower robot. That is the simplest robot that you can make. So in that, you are programming the robot, like detect the lines and keep moving through this line. Okay, so detect and keep moving over the line. Okay, so basically what we are doing is we are modeling the behavior, right? Behavior of the robot using some programming language. So if you are using an Arduino board, you are programming in Arduino language. Okay, so robot programming, we are modeling the behavior, and what is the input of this model? So imagine this is a model. Okay, so and the input of this model is the sensor values. Okay, excuse me for my handwriting. So the input is the sensors value. Okay, and the model is having the behavior, like if it is getting this some sensor value, it will model the behavior, and output of this model is the control commands to these actuators. Okay, so basically we are modeling the behavior of the robot, and you can use any programming language for this, but popular programming languages used in robot programming is C++ and Python. Okay, so these are the two programming languages that we are using frequently. Okay, so these are some of the features that we require for a programming language. That So I'm not discussing details about this, but these are some of the features that our programming language need in order to program a robot. Okay, so I'm not discussing details because this may have confusion. Maybe I'm just skipping this. I'm just coming to the methods, approaching different approaches of programming a robot. Okay. So I mentioned about the robot programming and what are the different approach to program a robot simply. Okay. So one of the approaches, you can write your program from scratch. Okay. Using some C or C++ or Python, you can write the entire code of the robot using this programming language. Okay. The problem is it's very time consuming. It will take a lot of time. Okay. But if you're planning for a product, then it will be good. So if you're planning for a long run, or if you're planning for a product, then I think it will be good. Okay. But the problem is it will take a lot of time. Okay. And it is difficult to create a stable code. Okay. You need a lot of testing, then only the code will be stable because we are writing from scratch, right? The next approach is what we are talking about is use existing software framework. Okay, meaning you are taking some existing framework from internet and modifying it and start working with it. Okay, so that's where the Arduino framework and the robot operating system is. So this is the position of Arduino framework and robot operating system. So we are using the existing software framework. Okay, so if you take Arduino, that is a microcontroller platform and a programming language used to program microcontroller, that is an existing framework. Okay, and we are just coding using that framework. Okay, similarly, the robot operating system is a framework, a software framework, which is used to build some complex application. Okay, so in Arduino framework, we can program a microcontroller platform, and it's very limited, right? It's a microcontroller platform, but a robot operating system is running on a PC, and we can do a lot of stuff. Okay, I can show demos maybe after these slides. Okay. So the advantage of existing software framework is it's very easy to prototype. You can quickly prototype it, and it's very good for academic research, because if you are doing an academic research, then you don't need to build all the stuff. You just focus on one topic. Okay, so the rest of the things you can take from these kind of framework. Okay, so if you're using in a product, then it needs a lot of fine tuning. So that is the problem. If you're taking an ROS or Arduino, then you may need a lot of fine tuning before converting into a product. Okay, so these are some of the existing software framework that can be used in programming robots. So the first thing is robot operating system. Okay. Basically, it's a communication middleware. Okay, I can explain that. Okay, but it's not a real operating system. Okay, the name says it's a robot operating system, right? But it's not the actual operating system like Windows or Ubuntu. It's called a meta operating system, meaning it is having some features of the real operating system. But the problem is it should need a host operating system to run. Okay, meaning it may need Windows or Ubuntu in order to work with. Okay, and you might heard about OpenCV, open source computer vision. So how many of you heard about open source computer vision, OpenCV library? Anyone? So you can comment it. Okay, yeah, good. I think some of you already heard about it. And there is a library called Point Cloud library, which is basically for handling the point cloud. Point cloud is 3D data, 3D image data, I can say, So OpenCV is only working with a 2D image, but PCL is working with the 3D points. Okay, so these are the important software framework that we are using for programming robots. Yeah. Now there are some simulators available. So if you want to simulate your robot, you don't need to write your code from scratch. There are some existing simulators like Gazebo, which is a robot simulator, open source and free to use. And there is OpenRave, which is using for motion planning. So if you have a robotic arm, if you want to move the robot from A to B, then you can use some sections of OpenRave. Then the popular simulators that is free and open source available are this WebBoards. So this is quite good. You can check it in the internet, WebBoards robot simulators. Then VREP is again another robot simulators. Then Actin, this is actually proprietary, but yeah. So these are, so WebBoards and VREP is not proprietary. There is a proprietary version of VREP, but WebBoards is completely free. Okay, so only the full proprietary software is active. Okay, so I work with all these simulators, and it's all good. It's all good. So you can have a try. Okay, if you want to work with the simulation. Okay, so these are the popular programming language that we are using: C++, Python, Java, C#, MATLAB. Okay, you might heard about MATLAB. There are a lot of work happening in MATLAB. So yeah. So yeah, we can start with the rows. So in order to learn robot operating system, what are the prerequisites to learn this framework? The problem is you need to know a lot of things before starting with rows. Okay, you might need the expertise in C++ or Python. Specifically C++ and Python in Linux, okay? Because if you're working with Windows, there are a lot of differences. I mean, yeah, there are a few differences. And also, you should have some experience with Linux operating system and Linux terminal commands, okay? So if you have this skill, then only you can start with rows. Okay. So this talk will be like basically an introduction to rows and how to learn rows. What are the advantages? What are the applications? So those things will be covering. Okay. Yeah. And I'm just want to give an idea about why we are using these rows or these framework in robots. Okay, just give an idea. So you might see a line follower robot like this. Okay, in the tech fest, there may be line follower competition. So in the line follower, we have a set of sensors on the front, right, to detect the line. So it may be an IR LED to detect the edges of the line. Okay, so after detecting these edges, the microcontroller here is taking the decision, like keep on moving over the line. Okay. So in this case, do we use a computer, fully fledged computer or laptop? No, right? We only use some microcontrollers. Okay. But if you are working with complex robot, for example, the popular robot that I can say is Asimo robot from Honda. I think you might see Honda Asimo, which is a humanoid robot. Okay, which is, I mean, it can do most of the functionalities like a human being. Or you may heard about Sophia. Okay, that is again a popular robot. So those robots we can say it's a complicated or complex robot because it is having two robotic arms, then head. It is having some sort of intelligence. So in those kind of robot, we may need more computation power. So not only microcontrollers, we may need a PC. Okay, it may be a workstation. It may be a single board computer. It may be a mini PC like Intel and UC. Okay, so there may be a PC along with the microcontrollers. Okay. And inside that, there may be some operating system, obviously. So inside a PC, there will be an operating system, right? So I'm just saying there are robots which is only working with microcontrollers or digital logic circuits, or with the PC. Okay, that is a fully fledged, maybe it may be a laptop or a mini PC or something. Okay, so in complex robots, a PC may be acting as the robot brain. Okay. Yeah. So why the reason is there are a lot of computation to perform, so that's why we need a PC. Okay. So these are the popular operating system that we are using inside inside the robot. I mean, inside the PC mainly. So Ubuntu is there, Debian, then Windows Embedded, and QNX real-time operating system, and VxWorks. So these are the real-time operating system. So actually in NASA rover, I think they were been using QNX real-time operating system. So these are some of the popular operating system that it's using inside a robot. Okay. So let's start with the robot operating system. Okay. So make sure you have these prerequisites. Then only you can start, but I can give you an idea about robot operating system. So I just want to start with the story. So this was my final year project. Actually, this was done in 2010. This is a robot called social robot. Sorry, the social robot basically it can work like the robot like Sophia. The robot Sophia, it is a chatting robot. Like you can talk to that robot and it can reply. Okay, so the same thing is doing by this robot. So it's like a animal kind of head, and it is having two eyes. There is lips here. These are the ears. There are two ears, and this head can move. Okay, so you can see a laptop here. There are two speakers. There is an embedded board here, and there is another laptop here. Okay. So this was my final year project, and this was me. When I worked with this project, this robot was not powered using ROS. Okay, so this was the configuration. It has 12 RC servos, 2 laptops, and 2 cameras. Then there was a provision to interact with people using AI, speech recognition, and face detection, motion detection. And I use Python and C++ to program. Okay. So this pic was taken during an exhibition. So this was the main challenges I faced. Okay. Simply, I can say, there are different programs running on these 2 computers. Okay. So you don't need to worry about the names. I can simply say there are different programs. Like, one program is for face detection, one program is for motion detection, one program is for artificial intelligence. So there are different programs are running. And these 2 programs are running from different systems. I mentioned that there are 2 laptops. Okay. So how do these programs communicate? Okay. At some point of time, the face detection program has to send some commands to the AI program. And the AI program should send some commands to some Arduino program. Arduino program is commanding the robot and it will move. Okay. So I have to establish some connection between these programs like this. Okay. So this was the diagram. Basically, there is a server. This was a thing I implemented. Okay. In order to solve this. There are some client programs. So you might heard about server client architecture, right? So there is a server, okay? And the client program can access to this server and exchange data, okay? So the server can communicate back to the client, and client can send some data to the server, okay? So in this project, I created computer vision, speech processing, artificial intelligence, and these nodes, Arduino serial nodes, to the server, and it will able to communicate with each other. Okay. But after doing this project in 2010, in 2014, I created a robot called Autonomous Mobile Robot, which is completely done using ROS. Okay. So the issue was, I mean, you can see the components, like this is an Intel NUC that I was talking about. There is a depth camera here. There are some embedded boards here. So these are the main components. Okay. And the function of this robot is it can go from A to B. So this is a point called A. And if we command the goal position here, this is B, then the robot can path plan and avoid obstacle and reach B. Okay. So I used ROS and Python C++ programming. Okay. So when I use ROS, I could solve all this issue that I faced during my final year project. The main thing was I could solve the inter-process communication. Okay, so that's what the term that we are using, like the communication between two programs. Okay, so using ROS actually it provides an easier way to communicate between two programs. Okay, so that is a main application of ROS. Okay, so you can just recollect the points that I have mentioned. ROS is a platform for doing inter-process communication. So, for example, you are running a program in C++ or Python called X. Okay, and you are running another program called Y. Okay, and also there is another program called Z. So these programs are running independently. Okay, and what ROS does is that ROS give you some functions. Okay, in order to communicate between X, Y, Y is Z, or X is Z, or in any pattern. And also, like, you can communicate back. And it's not only just communication, you can send data between these two programs. Okay, so X want to send a text called hello. Okay, then X can send to Y. If Y want to send an integer like 12, then it can send. Okay, so ROS is giving that power to our programs in order to communicate between two programs. Okay, so this is the ROS equation. Okay, you can find it from the ROS website. So if you have time, just go to the ros.org. Okay, this is the official website of Robot Operating System. Okay, so what is ROS? It's basically an open source robot software framework that we have already seen, and it's not a real operating system, but instead of that, it's called the middleware or a meta operating system. So what this middleware give is it will give the power to our programs to communicate with each other. Okay, and exchange data. Okay. And the thing is, it need a host operating system like Ubuntu or Windows in order to run. And this is called the ROS equation. Okay, so basically, the plumbing part, it's not the plumbing that we that we already know. Plumbing is basically saying the inter-process communication. Okay, plumbing is the message passing or the inter-process communication part. And along with this communication, it provides some interactive tools. Okay, what is the purpose of these tools? It can do the visualization of robot sensor data. For example, if you want to visualize the image coming from a webcam, then you can use tools. If you want to visualize a laser scan coming from a laser scanner, you can do these tools. Okay, so it provides some interactive tools, and along with that, it provides capabilities. So this is one of the important part why most of us are using ROS. Okay, the capabilities are simply, if you want to implement a robotic arm project, Okay, so you might be working with some finally a project or mini project. If you want to implement some inverse kinematics or some motion planning or any work using a manipulator or a robotic arm, then ROS is having some inbuilt packages in order to work with a robotic arm. Okay, so you don't need to write code from scratch and all. You can just use this package and just customize it, and it's ready to go. And also, if you want to work with some mobile robots, that is two-wheel or four-wheel robots, ROS provides some navigation stack packages in order to move from, in order to perform this A to B operation. That is going from, autonomously going from A to B. Okay. Then, these are some of the capabilities. Okay. And the last thing is ecosystem. ROS is having a lot of developers worldwide, and a lot of companies are using ROS now. So there is a lot of community-driven developers. There are a lot of tutorials. There are a lot of website featuring ROS, and a lot of people are creating tutorials on ROS. So that's all belongs to the ecosystem of ROS. So why this is important? Why ecosystem is important? Because imagine you are doing a project, okay, and you have seen a framework or some kind of code, and you started taking that framework, started using it. Okay, imagine you become stuck and you couldn't able to code further. So you should get some help from Stack Overflow or some other website in order to proceed, right? So if you're working with ROS, then there are a lot of platforms to ask your doubts and also to get support. Okay, so that is ecosystem. There is a good ecosystem available around this ROS platform. Okay, so just remember this these 4 points: plumbing or the inter-process communication, tools, capabilities, and ecosystem. So this is the main thing that I want to communicate with you. Okay, so these are the things: inter-process communication, tools, capabilities. That is, I mentioned that the manipulation, navigation, then the ecosystem. Okay. So this is a demo of inter-process communication. So this is program 1, program 2, and program 3 that is running on your PC. Okay, imagine. So using ROS, we can communicate from program 1 to program 2, then program 2 to 1. So this is just a demo. It can be in any ways. Program 2 or, to program 3, then program 3 to program 2. Also, maybe it can communicate to program 1, and it can communicate to program 3. So it is creating a graph actually. Okay. So in ROS, we are calling it as a computational graph. Okay. The term is important. It's called computational graph, meaning we are creating a set of programs. We are running a set of programs in your computer. Okay. And these computers are forming a communication graph. Like if you draw lines from 1 to 3, then 3 to 2 and 3 to 1, it's basically forming a graph, right? So nodes, so in the graph, you can see there are a lot of nodes. So this is kind of graph, right? So basically ROS enable us to create computational graphs. Okay, so why computational graphs? Because each program is performing some kind of computation. Okay, and each node, after performing computation, it may sending some data to another program. So this is the basic fundamental concept of ROS. Okay, so you might think, what are the things that we can use with this communication feature of ROS? You can do many things. Okay, I can show you the examples. Okay, so I hope you have some idea about this communication feature in ROS. So now it's a time for Q&A. I mean, I can take 5 minutes for Q&A. So till now, if you have any confusion, just let me know. You can just comment on the comment box, okay, first, then I can call your name. That would be better. Otherwise, a lot of people ask simultaneously. So if you have questions, just let me know in the comment box. Okay, so so the first question, I think, from Vishnu. So he's saying, so what is your opinion on using ROS on virtual machine? Okay, so basically today I'm going to show you the demo using VMware software, that is a virtual machine. So virtual machine softwares are basically helping to install an operating system without switching to another operating system. Meaning, if you want to install multiple operating system in your computer, you want to reboot your computer and switch back to Ubuntu or Windows. Okay, but using virtual machine, you don't need to switch. You can install this software called VMware or VirtualBox, and you can install Ubuntu on that. So for a beginner, I will strongly suggest to use virtual machine. Okay, because if you are installing Ubuntu without any idea in your system, what happening is that you may lose data. So virtual machines are good for experimenting. Okay, yeah, so it is good actually. Yeah, so if you have any other question, let me know, because these are some of the foundation. Okay, so if any doubts, let me know. So if you don't have any questions, then I can proceed it to the further, to the next slides. Okay, maybe you can ask doubts in chat box so that I can reply to your questions. Maybe during the presentation. Yeah. So this is the inter-process communication. I hope this is clear to you. Okay. Now, again, a practical example. Okay. Using ROS. So basically, there is a camera driver program. Okay. So here, there is a camera driver program. Okay, which is basically sending images to another program, which is performing face detection. Then the face detection program is sending the centroid of the face to another program. Okay, so this is how a ROS nodes working, nodes or program. Okay, so just imagine, like, you have a program that is just reading from the camera and sending images to another program. Okay, and maybe you can add some other programs here in order to detect motion. Okay, so that is also possible. And you can add some other programs here, so you can receive the images from this program, and you can do some color detection here. Okay, and you can send to another program. So this is a chain of programs communicating with each other. Okay, so that is the advantage of using ROS. Okay, and regarding the tools, ROS provides some interactive tools called RVs, RQT, and command line tools. I will show you during the demo. Okay, so these are the tools available, and this is RVs and this is RQT. Okay, so RVs is basically it's a 3D visualizer tool. So basically it's using for visualizing the 3D data. You can see this is the laser scan. This is a robot model, 3D model. And RQT is basically a 2D tool, basically for plotting 2D data, then debugging the ROS and robotic data. Okay. So these are the important capabilities. I just want to show you some demos, then only you can understand. The important capabilities of ROS are navigation and moving. So let's show you a demo first. Let me reduce the volume because it's actually videos. Yeah. So first, I just want to show you the navigation demo. So this is a simulation it's a Gazebo simulation. You have seen what is a Gazebo is. It's a robot simulator. So in this demo, you can see a robot which is using a warehouse. Okay. So this is a robot. Okay. So you can comment. You can just publish a goal position. Okay. You can just command the robot to go to some position, and the robot will go to that position autonomously. So this is the goal position that you have commanded. So what the robot does is that it will create a path from the current position to the final goal position. Okay. Then it will avoid obstacles. There is a virtual wall here. Okay, so you can add the virtual walls, meaning there is no physical wall, but you can add virtually. Okay, and it is avoiding that and is reaching to the goal position. Okay, so in order to do this project, okay, a lot of students are doing this autonomous robot project and with some other application. In order to do this, you don't need to code at all. It's all about taking this navigation stack and customizing the navigation stack. Okay. So what I'm trying to say is that ROS is having these features. Okay. You don't need to code it. You just take the package, customize, and it's ready to go. Okay. So this is one capabilities that is already available with ROS. Okay. So next is the manipulation. Manipulation means picking an object from A to B. Okay, you might see some videos of robotic arm which is taking some objects from the conveyor belt to some bins. Okay, so you can implement a complete manipulation package using ROS. So let's see a demo. So let me reduce the volume first. So in this demo, you can see a robotic arm here. And what it does is that, just a second, I can reduce the volume. Yeah, I can mute it. Yeah, so this robotic arm is detecting the marker. And this tool is RVIS, actually, the ROS visualizer tool that we have discussed. And it's detecting the marker and taking the object and putting it here. Okay. Then after that, it is looking for another box that is on the right side. So it is detecting the marker again. Okay. So it is computing the 3D pose. Then there is a camera on the tip. You can see the camera, and it is taking it and putting on the top, I guess. Okay, so these things can be implemented using ROS. It's not difficult. You can customize it like the navigation stack. Okay. So if you want to implement this kind of stuff, you don't need to write your program from scratch. You can use ROS. Okay. Right. Now, another capability that I want to mention is ROS perception. Okay. So perception means vision related task. Okay. Like we are perceiving the world through our eyes, right? So similarly, the robot is having a set of cameras or set of visual sensors like LiDARs, then depth cameras, etc. Okay, so in this diagram, in this screenshot, you can see this is the actual robot. This seems like an industrial robot, okay, which is using for industrial purpose. So what you are seeing around this robot is the obstacle. Okay, it's called the map, obstacle map, and it's 3D, right? You can see it's 3D pixels kind of thing. Okay, so what is the purpose of creating a 3D obstacle map around the robot? Okay, what is the purpose? The purpose is that if you want to move from the robot from A to B, okay, like the robot is taking an object from A and putting it in B, then if the robot doesn't know about the environment, it may be collide with the environment. Got it, right? Because when the robot plan its path from A to B, and if it doesn't know about the environment, then it can collide with the environment. Okay, so the perception stack or perception packages in ROS will give the ability of perceive the environment. Okay, so that robot can see the environment and it can avoid the obstacle. So this is an interesting demo coming. It's actually taken from a self-driving car. So you can see a car is driving from here to here, and you can see it is building a map, the 3D map. Okay, so they're using a sensor called Velodyne, that is a 3D LiDAR sensor. Okay, and you can see it is constructing the map of that city. Okay, so in order to do this, ROS provides the features. It's very easy to implement these kind of functionalities using ROS. Okay, so you can create this interactive maps like this, and this is visualized in RVs actually, and this representation is actually called the point cloud. Okay, so this is a point cloud map. Okay, yeah, so this is the entire map of that city. Okay, so you have seen the important features or capabilities of ROS. Now, regarding the ecosystem, there are a lot of users of ROS from United States, China, and we are in the 5th position. But now we are in the 6th position. This is not the latest metric. Okay, there are a lot of people are using ROS, especially from China, because a lot of Chinese companies are working with robots. Okay, so most of the robots, the internal part of that robot, that is a backend software, is powered using ROS. Okay, and the front end can be Android or some other GUI. Like you might see the robot having a screen on the chest. Okay, and you can interact for food ordering and delivery. Okay, so those robots, the front end is Android, the back end can be ROS. So these guys are, these countries are extensively using ROS. So what you can assume is that if you want to do an MS in robotics, for example, in the US, most of the robotics research institutions are saying you might need experience in C++, then Python, then ROS, OpenCV, and PCL. So if anyone want to do masters abroad, it may not be US, but in Europe also, even for Japan, they're also like looking for ROS developers. Okay. Now, yeah, and there are options to ask questions if you're working with a ROS project, and if you have any doubts, you can ask here. Okay. And in order to work with ROS, we can install ROS in Ubuntu or Debian. So Ubuntu is having full support. Okay. And in Windows also it will work now, but it's still experimental. Okay. So Ubuntu is the operating system that is fully supported of ROS. Then this is just a block diagram of ROS. It is having tools, then the middleware, then the libraries, client libraries, etc. You can just skip it. Okay. Now, for you, so you might think, what is the advantage of ROS? There may be, there are softwares before inventing ROS. That is, there are robot software before ROS. So what happened actually before ROS and after ROS? Okay, so for the robotic research, what happened was before ROS platform, the thing is that there was no common software development platform. Okay, actually, if I'm a robot researcher, maybe I'm working in with a robotic project at 2001. Okay, ROS actually started in 2008 to 10 time. So if I'm working at that time, what happening is that I will write all the code from scratch. Okay, and it will be specific to my robot. Okay, and no one can reuse the code because the code is very specific to that robot. Okay, and you might not see any active community around that. Okay, so before ROS, what happening was there are no simulators available, free simulators not available, and it was very difficult to collaborate with robot project. But now the thing is that everything changed. ROS is actually a common software platform, and the main goal of ROS is code reuse. For example, if you are working with a project, for example, your main project, okay, so you are doing an autonomous mobile robot, okay, and you created software based on ROS. So the advantage is that I can use your code without any modification. Okay, and I can install that package in my system. Okay, and also there are free simulators available. So if you install ROS, you will get free simulators called Gazebo. Okay, then the collaboration of robotic development is also possible. Okay, so now the question is, who created ROS? Okay, so the project actually started from Stanford. The name was different. It's called SwitchYard. And the original author was Morgan Quigley. Okay, so this was a base paper of robot operating system. So after that, so he is Morgan Quigley. I personally met him on a conference. So he's currently working with an open robotics that who are currently maintaining ROS. So what happened was after that SwitchYard project, in 2008 to 2013, there is a research institution called Willow Garage in US. So they started the ROS project. Okay, they taken that SwitchYard project and they started it. And in 2013, they actually shut down. And these are some of the robots actually using ROS. They developed this. Okay, Willow Garage actually developed these robots. Okay, it's called PR2 and Turtlebot. Okay, PR2 is for it stands for personal robot, and Turtlebot is actually for education and research. So the cost of this robot is roughly around $4 lakh. Okay, it's 40,000, 4 lakh USD. Okay, but Turtlebot is it's a cheap platform to learn ROS. Okay, so now ROS is actually maintaining by Open Source Robotics Foundation or Open Robotics from 2013. So this is the logo of Open Robotics. So they're mainly maintaining ROS platform and also the Gazebo simulator. So this is the team who is maintaining ROS and developing ROS. And next question is why we are using ROS for robot programming? Because we can reuse the code. For example, if some researchers in US develop a code for his robot, you can reuse the code. Okay, so reinventing wheel can avoid. Okay, you don't need to implement the same stuff that is already implemented. And the code is very, very modular, so you can just take the code and use it in your project. It's very modular and it's free and open source. Okay, and it is having great community support, obviously. And even ROS can apply in distributed computing. Okay, you can run ROS in multiple computers. Okay, so I'm just skipping to the distribution. Uh, so you might heard about different versions of Windows, right? Windows 7, Windows 8, Windows 10. There are different versions of Windows operating system. And if you heard about Ubuntu, there are distribution called Ubuntu, then Debian. So there are different Linux distributions available. Okay. So similar to that, there are ROS distribution. Okay. So what are these distribution in Linux? There is Ubuntu, that is one distribution. There is Debian, that is again one distribution. So each distribution is having a set of version softwares. For example, Ubuntu is having a specific list of software. Windows is having a set of another software. So similar to that, for ROS, there is a set of softwares. Okay, so that is called the distribution. Okay, it's very similar to Linux distribution. So these are some of the distribution name. It started in 2010. I mean, the Box Turtle was the first version. Before that, there was some experimental versions. Okay, so from Box Turtle, Sea Turtle. So you can see this letter is changing. In 2011, it's ROS Diamond Black, then Electric, MSys, then Furate, Groovy, Hydro. 2014 is Indigo, Jade, Kinetic. Then Luna, Melodic, and finally the Noitic. Okay, so this is the latest version of ROS, but the year is different. It's 2020 actually. Okay, so you will get support up to 2025. Okay, and this is called the LTS version. So you might heard about LTS. It stands for long-term support. So Ubuntu 20.04 is an LTS version, meaning you will get support up to 5 years. Similarly, the ROS installing on this version will be an LTS. Okay, and this is ROS 2 version. Okay, so the ROS 1 version, this is actually ROS 1. So that will stop its support in 2025. And after that, there will be only ROS 2. Okay, so currently the ROS 2 version is Foxy. Okay, so you can install ROS 2 Foxy in 20.04. Okay, so that is about the distribution. Now I can show you some robots that is supporting ROS. Okay, so the robot supporting ROS means it is completely programmed or partially programmed using ROS framework. Okay, so this is one robot called PR2. So just check on the configuration and just compare with your computer, your laptop configuration. This robot is having quad-core i7 Xeon processor, then 24 GB of RAM. It's great for gaming, right? So if you get this robot, you can take the computer and we can do gaming, right? And it is having 2 TB of hard disk, then 2 7 of ARM. This is ARM, and it is having a lot of sensors. Okay, so this is one sensor, this is another. Okay, and this is Turtleboard. This is another cheap alternative in order to learn ROS and doing research. So these are the other robots supporting ROS. Baxter, Ream, Pepper. These all belongs to service robots. Then Robonaut, Ream, Fetch, Talos. This is a humanoid robot. Then these are some robot manipulator. Okay, ROS supported manipulator, and again some mobile robots using ROS. Okay, so I'm planning to show you a demo that is actually the demo is created using ROS framework and executed in PR2 robot. Okay, so let's start. So I'm just muting the audio. So the basic idea is these engineers are working in Willow Garage and they need beer. Okay, so they need beer for chilling. So they created an application. So the application is simply fetching the beer from the fridge, okay? And who is doing the job? The robot does, okay? So let's watch this demo. So these guys are creating a software using rows. So if anyone need a beer, then he can order it and the robot will deliver. Okay, so this is a beer ordering interface, but you just see it is opening the fridge. So these all things are doing autonomously. Okay, and the robot is taking the beer, but just check it is running on 20x. So it's opening the fridge for maybe for 5 minutes. I'm not sure, and then only it can take the beer. So don't try this at home anyway. Like this is only for demonstration purpose. Yeah, after taking the beer, it is closing the fridge. Then it is checking whether the fridge is closed properly. Then it's delivering. Okay. And the good thing is that it can even open the lid. You can check. It can open the lid. Yeah, it can do much better than us, obviously. Yeah. So this is a demo, and this is completely done in rows. Okay. So coming to the next demo, the pool shark. Basically, the robot is playing the pool. Okay. So here, these engineers created a software based on rows, and using this software, the robot can able to play pool. Okay. So you can see the robot is playing pool better than us. And the good thing is that it's not randomly kicking the ball, okay? But instead of that, there is a strong algorithm running in backend. Okay, so that algorithm is detecting the balls. So you can see the balls are detecting, and it is planning the path. Okay, so this is the detected board with balls. Okay, and the robot is actually can do the path planning like this. It can iterate. It can simulate, like if it is hitting the ball in a particular angle, then where should be the ball should go. Okay, so we can't able to do that. Only a robot can do. So yeah, so this is another demo, but robot will fail at some time, obviously. Yeah, so that is the pool shark. Now again, next demo, the PR2 is making the popcorn. This is very interesting. They have these guys have done a demo during an exhibition. So basically, PR2 will take the popcorn, corn basically, and put it in the heater, and it will prepare. Yeah, you can see the robot is changing the knob and doing the work. Yeah, I can just seek it. Yeah. So this is basically a heater, okay? And you can see a sensor that is, basically a laser scanner. I'm just seeking. Yeah, now the popcorn is ready. And it's taking and putting into yeah. And finally, it will put salt on it. Okay. Yeah. So these tasks, all the demo is done using rows. Okay. So this is another demo. Basically, of the rows navigation stack. I can show you that the robot is moving autonomously, And what happens if somebody falls on the friend? It can avoid it autonomously. Okay, so this is again done using ROS. So there are a lot of demos. Actually, I'm just skipping, and I just want to show you some sensors next. Some of the sensors supporting ROS. Okay, and some boards. So now I'm just going to the important section of this. Okay, how this ROS, how this program can communicate with each other using this ROS functionality. Okay, so in the meantime, I can also show you these companies are using ROS. Okay, this is not the complete list. So if you learn ROS, there are a lot of companies are hiring. Okay, so the list goes on. And also, if you are planning for doing MS in robotics, the ROS is a mandatory skill. Okay, so this is one of the job opportunity that I found in Glassdoors. Okay, and regarding the future scope, software is a main or important aspect in computer, also in robots. Okay, so the Bill Gates actually transformed the computer industry, right? He released Windows operating system, and also the Linux also transformed. So similar to that, ROS is actually transforming the robotics software industry. Okay, so a lot of opportunities in research, and there are a lot of opportunities in. Companies are looking for ROS developers, especially in the US, and in India also a lot of companies are looking for ROS developers. So there is a ROS conference called ROSCon. Okay, so this was one of the photos that I taken during ROSCon. This was one of my last book called I just want to show you an important aspect of ROS. So after that, I can come back to the demo and Q&A. Okay, so let me go back to that slide first. Okay, so how ROS help two programs to communicate? So that is the last topic that I'm going to explain. So in the arranged marriage in India, the arranged marriage is famous, right? So what happening in arranged marriage? Maybe I can use the pencil. Yeah. Let's see. So what is happening in arranged marriage? So in arranged marriage, there may be a broker, right? Let me draw. Yeah. So in arranged marriage, there will be a broker. Okay. And I have used the Chavra matrimony as the broker. Okay. So what this broker does is that here is the boy, here is a girl, right? And the boy will exchange information to broker, and also girl exchange information to the broker. Okay. Then the broker will do a matchmaking. Okay. So if there is a match, then the broker will exchange data between these two people. Okay, so the broker will decide, hey, this boy is suitable for this girl. Then the broker will exchange the information of this boy to girl, and vice versa. Okay, then what's happened next? Then there is no need of broker. Okay, so after getting the phone number, the calling will start. Okay, so now the girls started chatting or calling to the boy. Okay. Okay, so this same thing is happening in ROS. Okay, there is a broker program. Okay, so what is the function of that broker program? That will help the programs to interconnect. Okay, for example, there is a program called Talker. Okay, so Talker is sending a text data. Okay, with a name called chatter. Okay. So this is we can call it as a data bus. So the talker is sending some data, and it will contact the master program, that is a broker program. Then again, there is another program called listener. So listener need this data, okay, the same data. So listener will exchange the data to the master program, okay. Now, if the master find a match between these two programs, then it will share the information and the connection starts, okay. Then it will directly send messages between these two programs. Okay, so this is how the communication happening between two programs using ROS. Okay, so this is a fundamental idea. Okay, so there are a lot of terminologies coming. You know, ROS is a vast topic, so I'm just giving some idea how it is working. Okay, so now I'm just quickly go back to the demo. So in the meantime, you can ask doubts. So what I'm trying to show you is that some simulation. So it might be interesting. So in the meantime, you can ask, you can either comment your doubts, okay? Then I can answer. So in the meantime, I'm setting some demos for you. So yeah, you can ask if you have any doubts, okay? So in the meantime, let me show you the demo. So the first demo I'm showing you is the warehouse robot. Let me start the warehouse robot simulation. Okay, so I'm starting the simulation of this warehouse robot in Gazebo. So this is the Gazebo simulator. And it will take some time. Yeah, here is the robot. Okay, so currently I don't have the actual robot, so I'm just showing the virtual robot in simulation. Okay, so this is the Gazebo simulation, and just unpausing it. Now I'm starting. So my objective is that showing the navigation. Okay. So let me start some commands. So these will help you to start the navigation. So let me know if you have any questions related to ROS, its opportunities and all, so I can answer specifically. Now, let's take the RVs in order to visualize the thing. So you can see this is a map of the robot, okay? And you can see the map robot here. Now, in order to move from A to B, you can simply give the goal position. Let's wait for some time. So you can see the path planned by the robot. You can see a green path that is called the global plan, and there is a red color or the green color. The blue color, which is the local plan. So you can see the robot is planning the path and moving over the path, and it's reaching the destination. Okay. So these kind of projects can be done using ROS. Okay. And let me put the goal position here. So that is inside the room. Okay. Let me see what happened. See, it's planned a long path. Okay. And you can see the robot is moving in simulation. Maybe I can put a random obstacle here. Let's see what happened. So it's detected that obstacle. Actually, it should automatically avoid that obstacle, but you have to fine tune it properly. I'm not sure what happened for this robot. So you can find the obstacle here. So yeah, it's taking a different path in order to avoid that. Sometime it will stuck. Yeah, I think it's gonna hit, and it's taking a different path, but it can't. So if you do proper fine tuning, then it will avoid it. But if I delete this object, then it will resume its operation. Okay, so let's see whether it can go through this. Yeah, I think it's going through properly. Okay, so that is the navigation demo. Okay, now we can see a manipulation demo, that is pick and place or moving from A to B in a robotic arm. Okay, so let me start a robotic arm simulation. I'm showing the simulation because I don't have the actual hardware now. So let me start the simulation. So this is a robot arm called UR5. Okay, so you can see the simulation here. Now I'm starting the other stuff, like for doing motion planning and everything. So now the RVS is popping up. So you can see the robot model here. And now you can do the motion planning. So the motion planning is very simple. Just press here. So this is the end effector or the gripper of the robot. So just move the end effector. And this is a God position, okay? You have to do the planning. Then let me show you how the simulation work. Okay. So here is the simulation robot, and if you press the plan and execute, it will execute on the simulator robot. And if it is an actual robot, this will execute in the actual robot. Okay, so you can move the robot here, then do the plan and execute, then it will move. So basically we are doing the inverse kinematics. You might heard about the term called IK. So we are setting the goal position and the robot is moving to that position. Okay, so there are a lot of maths involved in order to achieve this thing, but ROS is having all the features, so you can simply do this without any coding. Okay. Right? Yeah. Yeah. So these are the things. These are two things, like the manipulation and navigation. Okay. Let me close that. And finally, I have one more demo, which is again a mobile robot. So if anyone want to ask questions, let me know in the chat box. I'm not sure you got the things that I mentioned. Maybe I can show you a final demo using ROS and Gazebo. So I'm starting the simulation first. So this is a simulation for a robot which will cost around 36 lakh. But if you have the simulation, you can work with this robot without any cost. Now I'm starting the view robot and the mapping. So basically this demo is about moving from A to B. Okay, you can find the demo, just okay. So if I just give a goal position. Again, the robot will plan the path. Okay. And it will go to the goal position. Okay. So you can see the robot moving here. It will avoid the obstacles and all. So this violet color or the blue color indicates the obstacle. Okay. So if I give a goal position here, you can see the path is slightly curved because it is avoiding the obstacle. Okay, so the Agil is asking, is Arvis included with Gazebo? So Agil, Gazebo is a simulator, okay? And Arvis is a visualizer. So Arvis is actually a tool. Gazebo is actually a simulator. So when you install ROS, you will get Arvis and Gazebo. Okay, so let me show you the ROS website and the installation instruction for clarity. So ROS.org, you can just go to ROS.org. Let me close it. It is taking a lot of computation. So just go to .ros.org, sorry, ROS.org. So this is the official website. And if you go to the install option, you can find the options to install. So currently the latest version is Noitic. And so this is the installation instruction for ROS in Ubuntu. And just follow these commands, okay? And there is a thing called desktop full installation. So it is saying it is having 2D, 3D simulation and everything. Okay, so if you install this package, then you will get everything. Okay. Yeah. So now that is about the demo and installation. So I can also show you some simple demos. This is, you have heard about Iron Man, right? So using a ROS 2D simulator, we are drawing Iron Man using robots actually. So this is a robot caricature. Okay. Now you can even create some interactive games using this robot simulator called Turtle Sim. Okay. So these projects are done by my students. I'm running an online course now in ROS. So these are the projects done by my students. So yeah, so I just want to show you my course. The course is called ROS Developer Learning Path. Basically, like a 6 months course. Okay, so I'm explaining from ROS for beginners, that is for absolute beginners, to mastering ROS, then ROS advanced, then how to become a good ROS developer. So I am running this course now. So yeah, so if anyone interested, let me know. So any questions you can ask, or you can just note it down, like the details. Like if you have any further queries, let me know in my mail ID. The mail ID is Qbotics Labs. Maybe I can put it in the chat box. Gmail.com, and this is my contact number. And if you want to check my company website, this is the website, that is qboticslabs.com. Basically, we are doing ROS-based consulting and education. And this is my blog, which is having some tutorials. Okay. So if you don't have any doubts, we can wrap up. So it's 12:30 now. We can wrap up. And if any questions, let me know. Maybe you can just send a message or mail. Okay.
Sir, there is a question in chat box. What are system requirements for installing ROS?
Okay, then. So what's next?
Sir?
So I'm just stopping presenting. Okay.
Sir, sir.
So Kartika, you can proceed. I think I'm done with the presentation.
Okay, sir. Sir, there's a question in the chat box.
Sorry, the mic was mute. Okay. Yeah. Okay. The thing was, I was the volume was too low. Yeah. Now go on.
Sir,
Yeah.
there is
Yeah, I
a
can hear
question in the
you.
chat box. Um, what are system requirements for installing ROS?
Okay. So I'm seeing two questions. Okay. So the first question is, what are the system requirement for installing ROS? So if you're planning to install ROS in your computer, then it should have minimum of 4 GB RAM, then at least 100 GB or no 20 GB of storage space in your computer. I mean 20 is minimum, maybe 30 or 40 GB of hard disk space, and you should have a processor which is running more than 2 gigahertz. Okay, but if you are working with a virtual box or virtual machine, your computer at least have 8 GB of RAM and more than 2.5 gigahertz. Okay, then only it will work good. Okay, so that is the requirement, system requirement. So maybe first you can start with the VMware or VirtualBox. These are the virtual machine softwares. Okay, so you can start practicing ROS using that. Then you can install ROS on your system. Okay, so the next question is, which software is beneficial for Microsoft version? Which software? Okay, so basically, it's not very clear which software is beneficial for. Yeah, so if you are planning to install ROS on Microsoft, then they are giving some instruction, like you can download a package management software from Microsoft, and using that you can simply install this package ROS packages. Okay, so you will get Gazebo, RVs, and everything, and you can use the Visual Studio in order to program ROS code. Okay, so that was two questions. Then now, yeah, so. If you're working with Microsoft Windows, then there are different simulators available. We have Gazebo, or you can also use WebBots. That is better for working with Windows, and also VRF. Okay, maybe I can type it. You can just search. Okay. So if there is no questions, then can we wrap up?
If you have any further queries, you can post in chat box.
Okay. So there is a feedback form. Yeah.
Feedback form has been posted in the chat box, and all are requested to fill that feedback form.
Okay, so I'm just stopping the presentation. Okay. Thanks for listening me. Okay. So let me know if you have any further questions. So you can use my mail ID to ask questions, or just connect me in LinkedIn or something. Okay. So bye guys. Bye everyone.
Thank you, sir. For concluding the session, I invite Parvati for vote of thanks.
Thank you, Kartika. Good afternoon. To one and all, it is my privilege to have been asked to propose the vote of thanks on this occasion. Myself, Parvati, second year computer science student, on behalf of Robotics and Automation Society of IEEE MBCT and the entire team of organizers of this webinar would like to record my deep sense of gratitude to Lentin Joseph Sir for his wonderful session on Introduction to Robot Operating System. What fascinated me the most was his lucid way of presentation. Thank you, sir. Next, I would like to show our honest appreciation to Jijo Sir, Assistant Professor, EC Department, MBCT, for his laudable session. I may like to express our sincere thanks for giving an excellent coverage on this field. We also owe our gratitude to Mr. Vishnu P. Kumar for sharing his experience and knowledge on robotics. Being one among us, he is a real motivation to growing and aspiring engineers. I would also like to express my thanks to our beloved principal, Dr. Abraham T. Matthews, sir, whose gracious welcome words had led the event. Next, I would like to express our immeasurable appreciation to Shira sir, Jinu sir, and all other faculties for their instigating guidance, invariable encouragement, and invaluable suggestions that has led this event to a grand success. Last but not the least, I would like to thank all the participants who actively participated in these 2 days academic event. Thank you all. Above all, I thank Lord Almighty for all his blessings. Thank you and have a nice day.
Thank you, Parvati. After filling the feedback form, you can leave the meeting. I wish you all a good day. Thank you.